which we will conduct in the lab. So the first one is estimation of hydroxide by acidometry, the determination of alkalinity. This is also volumetric titrations, and determination of hardness of water. So by complexometry titrations, and calorimetric analysis, potentiometric titrations, and conductometric titrations, and estimation of ferrous ion by permanganometry. So except these three, calorimetric and potentiometric and conductometric analysis. So all other four experiments are volumetric titrations. So only for calorimetric analysis, so we need to deal with the equipment. It's called calorimetry. So colorimetric. So another is potentiometric titrations. So potentiometric and conductometric titrations. So we already covered in the theory class. So we will also do some experiments in the lab. But this these two also need some equipments. Okay. So all the rest of the four experiments are volumetric analysis. So with the volumetric titrations, so which we need conical flask, burette, uh, and indicators like phenolphthalein, methyl orange, and um, some other different required indicators. So this is the learning objective after completing the lab courses. So after completing the lab, so you should be able to deal with the water analysis techniques. So you should be able to determine the water hardness and the softness of waters, and we will be able to determine the quantity of metals present in the votes with the concept of adsorption. Also, you will be able to deal with some instruments like a calorimetric and conductometric and potentiometric, and it should be able to determine the saponification or acid value of some oils. So these are the course outcomes. So you'll be able to determine the water quality. So you should be able to access the metals present in the votes. So for example, iron votes. So you will be able to estimate how much iron present in the ore, and some chemical we will be able to deal with some analytical instruments which deals with the chemical analysis, and we'll be able to determine the acid value of different oils. Our first experiment is estimation of hydroxide present in the test sample. So by asymmetric titrations. So what do you need for this for these experiments? So one, you need a conical flask, which is capacity should be around 250 milliliters, and you also need a burette. So with all this, so you already came across in intermediates. I mean 10+2. So you might have done some titrations. Okay, so you already know what is conical flask, what is burette, what is pipette, and all this. Okay, and you will require some chemicals. So you need a standard sodium carbonate, HCl, and methyl orange phenolphthalein indicators. So what so it the experiments involves in two steps. So one is, so why do you need a see the objective of the experiment is to determine the hydroxide present in the test solution. Okay, so it requires, for this experiment it requires two steps. So one is, so you need to have the HCl, hydrochloric acid. So you need to estimate how much hydrochloric acid present in the solution. I mean, what is the concentration of HCl? You need to estimate in the first step, because so we need to use this HCl as the main titrant, against your test sample, because the hydroxide means it is a base. So you need a strong acid to titrate against the test sample, which is a basic solution. Okay, so in order to estimate the concentration of hydrochloric acid, so you take sodium carbonate, a standard sodium carbonate solution. So here you take a standard sodium carbonate solution. So it this reacts with the hydrochloric acid. So using some indicators. Okay. So indicators. Why do you need indicators? Because to estimate the end value, to determine the end value of the titrations. So sodium carbonate and HCl, it reacts and it forms a sodium chloride salt plus water. So is it right, the equation? Is it right or wrong? The equation is right or wrong? Anybody?
It's not balanced.
Yes, it is not balanced. Okay, so here there are 2 moles of sodium, but here there is only one. So and here 2 moles of chloride, here only 1 mole. So we have to make it here 2 NaCl plus H2O. So according to this equation, so what you can say that, so 1 mole of sodium carbonate requires 2 moles of HCl for reaction. Okay, so remember 1 mole of sodium carbonate requires 2 moles of hydrochloric acid to complete the reaction. So this is important because these values you will substitute in the equation. M1 V1 by N1 is equal to M2 V2 by N2. So here this is N1, this is N2. So N1 is 1, N2 is 2, and M1 V1 and M2 V2. So you will come to that in the next steps. So this is the first step. So the second step is wait. Yeah. So let's come in to some practicals for the first step. So we are talking about the first step, the first reaction, which is sodium carbonate plus HCl. So what you need? So you need different operators which we have already discussed. So burette, conical flask, beaker, and indicators. So first we need to prepare a standard solution of sodium carbonate with the concentration of 0.05 molars. Okay. And take you can pipette out 10 ml of sodium carbonate in a conical flask. And you have the HCl solution. So take HCl solution in the burette. So you can fix to the stand a clamp. So after pipette out 10 ml of standard sodium carbonate, so you add 2 drops of methyl orange indicator. So when you add this indicator, so the solution turns into light yellow color. So then we have HCl in the burette, we have sodium carbonate in the flask and also indicator. So then you start titration with HCl and the sodium carbonate until you get your end point. What is your end point? End point is the light yellow color solution is titrated against the base to get the pink color. So the light pale pink color is your end point. So when you get this pink color, so you have to note down your burette value. So what is in burette? HCl. So you will note down the value of HCl. So like that, we have to continue the titrations until you get the concurrent values. So here you put the values in the table. So value of sodium carbonate is 10 ml. In the burette readings, initial reading was 0. Now you have got 10.2. So final reading is 10.2 minus 0, so 10.2. So this is your final reading. For the second titration, this becomes the initial reading. So you don't have to refill it, you burette all the time. So now you don't have to refill the burette all the time to make it 0. No, you don't. The final reading of the first titration becomes your first reading, the initial reading of your second titration. So like that, until you get the concurrent value, you have to do at least 3 or 4 titrations. Okay, so in earlier classes, what maybe you might have done, so you might have done like 3 to 4 titrations, and you might have taken the average value. But here, no, we won't take the average value, but we take the concurrent value. That means, so if you don't get concurrent value means, so there is some manual error in your titrations. So maybe you are adding some less drops of HCl, or you are adding more drops of HCl. Okay, so by this, so you will learn the accuracy in the titrations. So this is the equation. So m1 v1 by n1 is equal to m2 v2 by n2, but here it is taken like ma va by na is equal to mb vb by nb. So okay, so based on this you already know. So ma concentration of HCl, so we have to estimate it. So mb is the concentration of sodium carbonate, which is already know 0.05. So acid is 10.1 ml. So which is given in the, which we have obtained the burette reading. The volume of sodium carbonate is 10 ml, which we have pipette out in conical flask. And the number of moles of acid is 2 moles according to the equation. And number of moles of base is 1 mole. So then we have to calculate the concentration of HCl. So this is your first step. The first step is done. So based on this, you substitute these values in this equation. So you will get the concentration of HCl. For example, 0.098 moles or 0.08 moles or 0.1 moles. So it depends. Okay, the next step is the estimation of OH minus. I mean hydroxide present in the test sample. So whatever you have done here, the titrations, the same titrations we will repeat the titration, but we don't need sodium carbonate. So instead of sodium carbonate, then we will use the test solution which contains hydroxyl. So in the same way like previous, so you take HCl solution in the burette and you pipette out your unknown test solution. It's a 10 ml in conical flask. Add 2 drops of phenolphthalein indicator. And earlier we have used methyl orange is the indicator, but here you use phenolphthalein is indicator. So when you change the indicator, certainly the colors of the solution will change. So after adding the phenolphthalein, so it turns into pale pink color. After titration with against HCl, you get colorless solution. So when you get colorless solution, that is your end point. So you have to note down your the burette reading. So like in previous table, this also say exactly more or less same, but here you take the NaOH, I mean your test solution is 10 ml. Here again burette readings. So you have to titrate until you get the concurrent value. So this is the burette reading. Burette means the HCl volume. So you already know the volume of HCl. You already know the volume of your test solution in which the hydroxide present. And you already know the concentration of HCl. Okay, so you already know the, so where you already have the N1 and N2 values. How? Where is the equation? Yes. So this is the equation for your second titration. So with HCl plus OH minus the hydroxide ions. So it reacts and it forms water and chloride. So here, for example, if you take NaOH, so there must be NaCl as a salt, it forms, and then water. So that means 1 mole of HCl is equal to 1 mole of NaOH. So 1 mole of HCl it requires to react with 1 mole of NaOH. So that means N1 is 1, N2 is 1, 1. So again, to take the same equation, M1 V1 by N1 is equal to M2 V2 by N2. So here MB is a concentration of hydroxide, so which we have to estimate it. So concentration of acid, you already estimated with the first table, first iterations. So on the volume of HCl, acid is already with the burette reading. The volume of hydroxide, it's a the conical flask pipette, you have already pipette out 10 ml. And number of moles of acid 1 mole, number of moles of hydroxide is 1 mole. So then substitute the values, substitute all these values in this equation, you get concentration of your hydroxide. Okay, so you will get the concentration of your hydroxide, for example 0.1 moles, for example. Okay, and then what is your objective of this experiment? So you have to estimate the amount of hydroxide. So for the amount of hydroxide present in the given sample is equal to the concentration of your hydroxide into molecular weight of hydroxide. So molecular weight of hydroxide is 17. So hydroxide is OH. Oxygen molecular weight is 16. Hydrogen is 1. So that means OH is the molecular weight is 17. So the concentration multiplied with the molecular weight of the hydroxide, then you will get the exact amount of hydroxide present in the test solution. So that is in gram per liter. Yes, this is your Can can you see the screen?
Yes, sir.
Okay.